Why are ORMs key for database transaction management? Have you ever wondered how developers manage transactions in databases without losing their minds? Today, we will discuss why object-relational mapping tools are essential for database transaction management. First off, let's clarify what a database transaction is. A database transaction is a series of operations that must either complete entirely or fail completely. This ensures that your data remains consistent and reliable. Managing these transactions manually can be tricky and often leads to mistakes. This is where object-relational mapping tools come into play. Object-relational mapping tools provide a way to interact with databases using objects instead of writing complex structured query language statements. This abstraction layer simplifies the process and reduces the chances of errors. With object-relational mapping, developers can focus on the logic of their applications rather than getting bogged down in database syntax. One of the key features of object-relational mapping tools is that they automatically handle the starting and management of transactions. When you perform operations through the object-relational mapping session, it begins a transaction for you. This means you do not have to write additional code to start a transaction. Additionally, object-relational mapping tools offer simple application programming interfaces for committing or rolling back transactions. This built-in error handling ensures that if something goes wrong, the database can revert to its previous state without any hassle. Imagine making a mistake during a transaction and having to manually fix it. Object-relational mapping takes care of that for you. Another benefit is the support for nested transactions or save points. This feature allows developers to have more control over complex operations that may require partial rollbacks. For example, if you are updating multiple records and one fails, you can roll back just that part without affecting the others. Object-relational mapping tools also integrate seamlessly with application frameworks. This means you can use annotations or decorators to define transactional boundaries, which reduces the amount of repetitive code you need to write. Take Python's Alchemy as an example. When you start a session, it implicitly begins a transaction. You can add or modify objects and then commit the session. If an error occurs, Alchemy will handle the rollback automatically. This makes managing transactions much more intuitive. From a backend development perspective, object-relational mapping tools help reduce the need to write complex structured query language statements. This allows developers to concentrate on the core business logic of their applications. Moreover, object-relational mapping improves code maintainability and readability. By representing database entities as objects, the code becomes cleaner and easier to follow. Another advantage is that object-relational mapping ensures consistent transaction handling across various database systems. Since object-relational mapping abstracts the differences in transaction implementations, you can switch between different database management systems without rewriting your transaction code. In summary, object-relational mapping tools make database transaction management much more accessible. They provide a higher-level interface for handling transactions, which simplifies back-end development involving databases. So, the next time you think about managing database transactions, remember how object-relational mapping can make your life easier.